Hello there, Nareg is here, and today I'm going to solve the third exercise from 2017 session, the first session, chemistry, which is an exercise related to electrochemistry. So, electrochemical cell. Metals tend to lose electrons, but this tendency is not the same for all metals. Document 1 shows the increasing order of the tendency to lose electrons of some metals. So, regarding the document 1, as you can see, Mg, which is magnesium, it will have it's the metal which has the highest tendency to lose electrons. Then comes the aluminium, then comes the copper. So among the metals present in the document 1, indicate the one which has the least tendency to lose electrons. The least tendency, it will be copper because it is located on the left side. The more you go towards the right side, the more the metal will have a higher tendency to lose electrons. Document 2 represents the schema of a functioning electrochemical cell AlX. We don't know the metal, the second metal. By referring to document 2, show that the aluminium strip is the anode. So we need to find out a certain indication that tells us that aluminium is actually the anode. So once we check the document 2, we can find out the orientation, the direction which the electrons are taking. It's from aluminium strip towards the metal X, the strip X. So aluminium is losing electrons more easily than the metal X. That's why aluminium will be the anode. All right. By referring to document 1, identify the metal X. The metal X, the strip X, it should be a metal which has a lower tendency, not higher tendency than aluminium. Aluminium is already the anode, so we need to find out a metal which is losing electrons much harder. That's why it's copper. So the X strip represents actually the copper. Choose among the schematic representation given below the one that corresponds to this cell. Now, conventionally, you should have aluminium, which is placed on the left side. So, in your schematic representation, we have to start by Al. It's not Al3+, so the first one we rejected. The second one, Al3+, salt bridge, X2+, X. It's a good one. And this last one is X2+. Again, I cannot have the cathode on the left side. The anode half reaction is Al, which gives us Al3+ plus reactant. Write the cathode half reaction. The cathode half reaction is actually Cu2+. It's the cathode copper plus 2 electrons will give you Cu solid. Deduce the equation of the overall reaction of this electrochemical cell. In order to do the overall equation, you need to multiply the half reaction at the anode by 2 and reduction reaction by 3. So the overall reaction will be 2Al plus 3Cu2 plus. It gives you 2Al3 plus 3Cu. Justify why the strip of metal X becomes thicker during the functioning of this cell. It becomes thicker actually because at the cathode we have a reduction. So Cu2 plus is being transformed to Cu. And whenever I'm having Cu solid, it means that the strip will become, of course, a little bit thicker than its initial state. Give one role of the salt bridge in an electrochemical cell. You can say that the salt bridge, it helps for the electron neutrality, or it can help to close the circuit in order to have the normal passage of the current. So that was all for this exercise number 3 from session 2017, the first session at chemistry. I'm going to ask you to subscribe to my channel. You'll be notified whenever I upload new material, whenever I solve new exercises. I can also share with you my Instagram and Facebook account. You can contact me directly or you can simply leave a comment below. That's all for this time and see you later.